Okay, so guys, we have discussed our chapter 3 in the previous class. Okay, siapa yang drop tapi belum tahu keputusan dah drop ke tidak. So untuk add and drop, you need to ask your academic advisor. Academic advisor will know because we are using SMP system. When your academic advisor allow or approve your drop subject, then it will be dropped. It's just the system. Okay, and then you can check in your SMP, is it still there, or the subject is not in your list in SMP. Okay, so please refer to your SMP and then please ask your academic supervisor. Okay, nak kena join kelas juga ke? My advice is just join. What if your academic advisor did not approve your drop this subject? So to be safe, just join the class for me. Okay, that's my advice. Okay, so siapa yang baru datang, siapa yang baru masuk, saya ada bagikan link untuk attendance dalam my chat box. Okay, ada foreigner? Any foreigner? No. Kenapa kalau ada foreigner nanti saya cakap bahasa Melayu dia tak faham. Okay, so class, we have discussed our chapter 3 in our previous class. This is chapter 2. Okay, so salah chapter. We have discussed our chapter 3. This is chapter 3. Force system resultants. Okay, this is about moment. Okay, so we have discussed about the moment, and it is about moments which is force times the distance. Okay, so in this chapter we will learn about the couple moment couple, and the equivalent system of forces and moments, and also the resultant force and the couple system for force and moment. Okay, so we have learned, and I have draw you the moment, how to determine, how to calculate your moment. It is from F, force, load given, and also the distance from the load to the point that you want to look at. Okay, the application is about the wheel and the lug nut. Okay, so it is depends on the force, and also it is depends on the distance. Okay, so I have explained the an introduction of the movement. So I hope that you have looked back if you not understand, and I have uploaded the previous class about this one. Okay, there about the magnitude, which is perpendicular, and we have direction, and always we mostly we assume that counterclockwise is positive. Okay, so so we have discussed about this one. We have calculate our examples. Okay, and this is the another examples of breaking your force into x and y direction, and then calculate your moment at point. And we have discussed this one, the maximum and the minimum. And now we are going to discuss about this question. Okay, so the question is, given a 40 Newton force is applied to the wrench. So we have a wrench, and the question is, find the moment of the force at at O. So where is O? Here is O. Okay, we need to find the moment there. So from the moment M is equals to F times D. So it must be perpendicular, so 90 degrees. Okay, must be 90 degrees. So you have 40 Newton, and then you have your point at O. Okay, so then what you need to do, you need to break your given force at A into X and Y, and then you need to find the distance for X and Y. Okay, so for this one, we have 40 Newton, and then we break it into two. The first one is 40 cos 20 degree, and the other one is here 40 sine 20 degree. Okay, so that is the break of force for 40 Newton. Okay, then you need to determine your distance. What is the distance for this one? 40 cos 20. What is the distance? Guys, for 40 cos 20, what is the distance of that force? Can you tell me what is the distance for 40 cos 20 degree? 30 mm, 230 mm. Okay, so there are two answers of 200 and 200 mm and 30 mm. So uh, the principle of our movement is perpendicular. Okay, perpendicular, and that is the distance that we need to know. Okay, so the distance for 40 cos 20, okay, we have this one, 40 cos 20. This is the line of action. Okay, this is the line of action for 40 cos 20. This is the line of action. So which line is perpendicular to the point O? Okay, so we need to find the line that perpendicular to point O. Okay, so this is 40 cos 20. Then this is the line. I just put it here. This is 40 cos 20, and this is the line that you should use. The line is 200 mm. Okay, so you put your force here, 40 cos 20, and then you need to find your distance. So which is the distance? The distance is 200 mm. Next, you have your 40 sine 20, and obviously it is 30 mm. Okay, so this is the line of action of our force. And then where is the perpendicular line? So we find that this is the perpendicular line of our line of action for our force, and then this is our force 30 sine 40 sine 20 degree. So that is our distance. Distance is 30 mm. Okay, so that is how we define our distance. So it need to be perpendicular. So ni this is setiap sem, every semester akan ada yang salah untuk pilih distance. Okay, so that is why I need you to understand carefully and write and jot down your answer very carefully so that the distance is correct. Okay, you write your okay. Okay, so that is our distance. So the moment at O, we have our moment at O. We have settle our x and y force axis, and then we need to determine moment at O. So we take the moment at O here, okay, and then we have our first force and our second force. Okay, so moment at O, summation of moment at O, we assume that counterclockwise is positive. Moment at O is equals to, the first one is we have 400 cos 20. So from the point O, okay, we look at the 40 cos 20, the first force first, and the first will act clockwise or counterclockwise from point O. Clockwise or counterclockwise. Clockwise. So you pin. Okay, so thank you for the answer. Yes, it is clockwise direction. So you pin your point at O, and then you look at your force. So 40 cos 20 will make it clockwise direction. If clockwise direction, you can use negative 40 cos 20. Then don't forget to put your distance 200 mm. Okay, 0.2 meter. So this is F, this is D. F1, D1. And then you look at your second force, which is 40 sine 20. Okay, So if you pin your point O, the force will act. Yes, we need to change to meter. I prefer to change it. Actually, it depends on the question. Actually, but normally I will prefer to change it at the in the equation, because of sometimes you guys forget to change it back. Sometimes after you calculate, then oh, is it mm or cm or meter? So I prefer to change it at the first time you calculate. Okay, but somehow sometimes I didn't change it. Sometimes actually it depends on the question, but for you guys I prefer you to change it to meter, because when you get your final answer you can change it to tera, beta, kilo, whatsoever, because of your 10 to the power of x. Okay. Okay, back to our question. So we need to find our 40 sine 20. So for 40 sine 20, when we pin at O, it will move counterclockwise. Okay, so counterclockwise positive, we have our positive 40 sine 20. And don't forget your distance. Distance is 0.03. Okay, this is F2 and this is D2. So we can calculate our okay, okay. So we can calculate our moment. Okay, so this one, nampak? This one in the examples, they did not change. Okay, so they did not change, but they put it there. So actually, you need to know which unit you are using. Okay. Then finally, at the final answer, M is 10 to the power of -3. Then it change 1, 2, 3 point. Okay, 7.11 Newton meter. Okay, so why it is negative? It is about the direction. So positive 7.11 Newton meter is on your clockwise direction. Okay, find the moment of the force at A. Okay, find the moment of the force at A. So question number 1 is lah. You need to find your force. So this is F and this is D. So moment is equals to F times D and 100 Newton times 2 meter. Okay, so we have 200 Newton meter. Okay, next, oh sorry, dah ada A ni. Okay, okay, question B, 50 Newton and the distance is, what is the distance for question B? This is 50 Newton. Okay, this is distance. This is force, and you need to find your D. Which D you gonna use? This is sigma moment at point O. Okay, so point O. We have O here. We have O here. We have O and we have O. Okay, they are the same. Okay. So the answer is 0.75. Thank you for the answer, 0.75. Okay. So if you are still blur how to find the distance, okay, so I will move the 50 Newton here, and this is the line that act perpendicular to our 50 Newton. So the line that act perpendicular form our force, and this should be the distance. So the line that you draw is the distance. Next, C. C is 40 kilonewton. And what is the distance? This is our F. What is your D? D is equals to D is equals to okay. What do you need to do? We have our F 40 kilonewton. What is our D? What is our line of action for the force? And then what is the distance, the line that we draw perpendicular to our force? 4.31. Okay. There are answers 4.31, 4.3085. Others, what is your answer? Surya Prakash 4.31, Azhari 4.3085, Lei Chong 5.732. Okay, your distance is, okay, what is your action line of your force? This is your action line of your force. Okay, so that one is your action line of your force. Okay, next, this is your force. What is where is the perpendicular line? Perpendicular line 90 degrees from our force action line. Okay, so from O, this one is 90 degree. So what is our D, distance? The one that we draw here. Okay, here. Okay, so this is our D, 4 plus 2 cos 30. 4 meter plus 2 cos 30 degree is equals to 4 plus 1.732 equals to 5.732 meter. Okay, so we have our force 40 kilonewton, and we need to find our perpendicular line. Okay, next. Any question about this one? Okay, saja je dia bagi tu 2 meter yang sengit tu. Any question about the C? Kalau ada tanya, okay? Okay, next. We have question D. A 60 kilonewton, and what is our distance? Show me, tell me the distance. What is the distance? Question D. What is the distance? Thank you for the answer. Okay, so bukan 3 meter, right? So, apa kita kena buat? Macam biasa, buat line of action. And then, mana yang perpendicular daripada O. So, kita mula daripada O, perpendicular kepada line, perpendicular to the line. This one. So, this is our distance. This one. So, this is our distance. So, distance is this one. Okay, 1 sine 45, 0.7071. So we have 90 kilonewton times 0.7071. Okay, right. Okay, tak apa, silap sekarang tak apa, it's okay, no problem. Tapi jangan silap masa midterm. Okay, finally we have our 7 kilonewton. What is our distance? Show me your distance from O. So you have O. Okay, you have your line of action here, your force, and then you need to draw from your O perpendicular to your line of action, and this is the distance equals to 4 minus 1 equals to 3 meter. Okay, then you have your moment 7 times 3 kilonewton meter. Okay, good. That is the simple exercise. And if you don't understand, please do it again and again. Yeah. Okay. So this is the answer. I just show you how to get your distance. Sebab ni penting nak dapatkan distance tu penting. Masih ada yang masih belum nampak. So please do it again and again and understand how to get your distance. Okay. So the tips is action line. Okay, action line of our force, and then perpendicular from the point. So from the point to the action line, that is our distance. Okay. Okay, pop quiz. Using the counterclockwise direction as positive, the net moment of the two forces about point P is, the point P, sigma moment at P is equals to counterclockwise positive. So berapa? Kira. Keluar cek. Okay, dah habis kira. Ada yang dah bagi jawapan. Thank you for your answer. So, bagi yang masih mengira, teruskan continue calculation. Okay, how to get your moment at P? Okay, so we have the F1, 10 Newton, D1, D1 3 meter, F2 5 Newton, D2 2 meter. So we look at our F1 first. We have FD 10 Newton times D1 is 3 meter, which is this one from P is acting counterclockwise direction. So it should be positive. Okay. Then we have 5 Newton for F2 and D2 2 meter. And this is when you fix your P, the 5 Newton will act clockwise direction and it is negative. So we have 30 minus 10 equals to 20 Newton meter P. Okay? Next example. Force F acts at the end of the angle bracket. Determine the moment of the force about point O. So this is what we want to look at. So we have our moment at O equals to berapa? Okay, moment at O is equals to berapa, and then we assume that this one is counterclockwise is positive. Okay, so first of all we need to find our F and also D. So we have F and D, and from the figure we need to break our force into X and Y direction. So for X direction, we have 400 Newton times, apa ni? Okay, so we have 400 Newton cos 30. Then kita ada 400 Newton sin 30. Okay, ini simple je tau. Okay, nampaknya okay, baru dah cakap. Nampaknya semua masih tidur, tapi ada seorang yang bangun. Okay, so we have sin 30. So ada yang now tengok je kita dah tahu kat mana kan. Terbalik je, saja je. Okay, maksud dia mata tu masih terbuka lagi lah. So 400 sin 30 and 400 cos 30. Okay, so next we need to find our D. So for our D, we need to draw our line of action for force. So this is the line of action for our 400 sin 30. This is the line of action. And then from O, we draw the perpendicular line. So this is our distance. Distance is equals to 0.2. Okay, so we have sigma moment at O, counterclockwise positive. Okay, for if we pin at O, 400 sin 30 is counterclockwise direction. So dia kat sini ni sini 400 sine 30. So it is positive. And don't forget your distance is 0.2. This is your distance. Then 400 cosine 30. So this is your force action. And from O to your line of action, this one is perpendicular. So this is the distance. So the distance is 0.4. So we have 400 cos 30 times 0.4. Okay. So if we fix at O, and we will find that 400 cos 30, 400 cos 30 is going counterclockwise direction. So this one is, clockwise direction. So it must be negative. This one is counterclockwise. Yes, line bawah angle mesti cos. Yang touch dengan angle mesti cosine sebab dia adjacent. So kah. Okay. Tadi saya saja je. Saya terbalikkan. Tapi ada yang sedar. So okay lah. Which is good lah. So kita dapat calculate kita punya moment at O. So this is our moment at O. We get negative. Okay, negative, and this is counterclockwise, and the positive mean clockwise direction for positive. Okay. The Achilles tendon force FT. So FT is mobilized when the man tries to stand on his toes. As this is done, each of his feet is subjected to a reactive force of NT. NT equal, this is NT, okay, 400 Newton, 400 Newton. If the resultant moment produced by force Ft and Nt about the ankle joint A is required to be 0. So sigma moment is equals to 0. Moment dekat A, okay, equals to 0. Determine the magnitude of Ft. Okay, buat sekarang. Buat sekarang. Letak gambar kaki, habis semua. Okay. Now get your calculator and calculate. You get 680 Newton for your answer. Sekejap saya nak menjawab. WhatsApp. Okay, dapat 680. Okay, so the first thing is you need to draw your um, diagram. Okay, your force in your diagram. So the diagram is you have 200 meter and force and E, then you have this one, then you have 100 mm. Here, this is your 400 meter, then this is your FT, this is 5 degree angle. Itu saya besarkan lah, sebenarnya kecil je. If the resultant moment produced by Ft and Nt about the ankle joint A is required to be 0. Okay, so dia cakap dekat A. So this is our A. And then we have our 0.2. Kita tekan nanti lah. Kat sini tulis 200. So this one is 200 mm. This one is 65. This one is 100 mm. Okay, so dekat point A, what do we have? We have our 400 Newton F, line of action, and then we have our D. So this is 400 times 0.1, okay, 100 meter. Then we have our FT cosine 5. And then we have here this one. So Ft sine 5 is not calculated as moment sebab tak ada distance. This is the line of action. So kena dekat A. So it touch A for the line of action. So we have sigma moment at A is equals to 0. Okay, so we have positive. Okay, so we have 400 Newton times the distance is 0.1 meter. Okay, and then we have, this is positive, we have another Ft cosine 5 degree times distance is 0.065 equals to 0. So Ft, if we point at A, Ft cos 5 will react clockwise direction. So it is negative. Okay, so we can find our Ft is equals to 400, 0.1, 0.065 plus 5. So we have 617.7. Okay, ada problem? Ada nak tanya untuk soalan ni? Do you have any question for this exercise? Okay? Ada Kalau ada, tanya tau. Lambat pun tak apa. The tool at A. Okay, next we go to our next exercise. The tool at A is used to hold a power lawnmower blade stationary. So, ni blade dia lah. Okay, blade. So, this is the tool A. Tool A. Dia nak loose the nut. Okay, nut is being loosened with the wrench. So we have a wrench. If a force of 15 Newton is applied to the wrench at B, so this is 15 Newton, in the direction shown, determine the moment it creates. Moment it creates about the nut C. So kat C, so sinilah moment at C. What is the magnitude of force F at A? So dia nak tahu F berapa. So that it creates the opposite moment about C. Creates the opposite moment about C is summation equals to 0 lah. Why so didn't? Mana-mana? Yeah. 100 meter, 100 mm is 100 times 10 to the power of negative 3 meter. So nak buang 3 ni, 1, 2, 3. So this is point, 0.1. Okay, bukan 0.01. 0.01 kalau kita ada 10 mm. So 0.01. Okay. Okay, so sambung balik moment at C. Okay, itu yang kita nak. Dan apa yang kita perlu buat. So we have this one is 400, this one is 300, and then we have 50 Newton, 60 degree. We have here 12 point. F 13, 12, 5. This is 400. This is 300. Anything else? Okay. So this is our C. This is our A. And this is our B. Okay. So we are focusing on the moment. Okay. Dah hilang pula semua. Okay, so kita tengok kat sini lah. So for moment, okay, untuk moment we calculate at C. Okay, so moment at C is equals to 0. So we have to be safe, you need to draw all of the force, the braking force. Okay, so this one is 12 over 13 F. Okay, and this one, which is not included at point C. So because of the line of action is on the line C, but just write it 513 over F. Okay, then we have next our 50. So tadi yang touch dekat theta, sudut yang touch dekat line ni adalah cosine. Okay, 50 cos 60, and this one is 50 sine 50 plus 60. Okay, so for point C, kita tak tengok yang ni. Okay, and for point C, kita tak tengok yang ni. Sebab tak ada distance. The action, line action of the force is on line C, kena line. So we have our F, okay, and we have our distance. This is the distance for F, and we have our F here, and we have our distance. Okay, so we calculate our we calculate our moment at C equals to 0. We assume that counterclockwise is positive. Okay, then we have this one. Okay, so this one is 12, 13 F, and we have this one 50 sine 60. Okay, yeah, number 2 and number 1. So 1 and 2. Okay, so we have at point C 12, 13 F, and don't forget your distance. Your distance is 400 mm, 0.4. And when you fix your C, the force will act counterclockwise, and this is positive. Okay, for number 2, for second force, we have 50 Newton sine 60 times our distance 0.3. Okay, and then when we pin our C, the force will act clockwise direction. It is negative, equals to 0. Okay, and solve the problem. Okay, you get F equals to 0.3 50 sine 60 times 13 divided by 12, 0.4. F equals to 55. Okay, answer, and this one is actually this one, 12.99 meter. Okay. Oh, banyak kita buat. Okay, Han. Now, we are going to moment of a couple. Moment of a couple, this is, you have two moments. Okay, no, two forces that act with the same magnitude but with the opposite direction. Okay. Students will be able to define a couple and determine the moment of a couple. So from the figure, we have F and distance. We have F and distance. So this is our point O. Okay. A torque or moment of 12 Newton meter is required. So this one required 12 Newton meter. To rotate the wheel, which one of the two grips of the wheel above will require less force to rotate the wheel? You think F will act less or F prime will act less? We have F and F prime. So we have moment. Moment is equals to F times D. Okay. Then we have 12 Newton meter. And we have F times 0.2. Okay. F times 0.2 plus, so we assume that one is positive, clockwise is positive, okay? Senang untuk kita anggap kedua-duanya. F times 0.2 plus F times 0.2. Okay, so this one will act clockwise direction, and this one will act clockwise direction also. So you have 0.4 F. So your F is equals to 12 divided by 0.4, 30. And this one is 12 equals to F prime times, this is your distance, 0.15. Ada soalan ke? 0.15 plus F prime 0.15 meter. So F, you got 12 equals to 0.3 F prime. F prime is equals to 12 over 0.3. F prime is equals to 40 Newton. So which one is less? F equals to 30 Newton. So if you have longer distance, higher length, and then you give the force, it will result in a bigger moment. Okay, so if you have less distance length, it will give you a lower moment. Okay, so this is the couple moment. So actually for this one, okay, the calculation for FD, M is equals to FD. So we just take only one F and one D. Okay, so we have 30 Newton times 0.4 M. Okay? So we have 0.4 M. Okay. So from that, this one, this is couple, okay? So from dividing by 0.2, 0.2 each of this one, okay, you just use the same same amount of force, and you just use the total length. Okay, so it will give you 12 Newton. That is a couple. In statics, a couple is defined as separated by a perpendicular distance. So couple, what is couple? A, B, C, D.
Meow, meow, meow.有人好像挠我红啊！你们不要打先，那我也做退先。
Okay, the answer is D. Equal magnitude, sama tadi 30 Newton in opposite direction. So satu left, satu right. Okay, thank you for the answer. So this is moment of a couple. A couple is defined as two parallel. So it is parallel. So this line is parallel. The line is parallel. Selari with the same magnitude but opposite in direction, separated by a perpendicular distance. So this is the, so we use the total distance D. Okay. The moment of a couple is defined as mf times D. Okay. Kat sini rupanya. The net external effect of a couple is that the net force equals 0 and the magnitude of the net moment equals F times D. Okay, so ni samalah, moment equal to 0, lepas tu moment F kali D. Since the moment of a couple depends only on the distance between the forces, so the distance between, so 0.4 tadi, 0.2 lah each. Between the forces, the moment of a couple is a free vector. So free vector boleh bergerak ke mana-mana, means it can be moved anywhere on the body and have the same external effect on the body. So moment can be moved. Okay, the figure moments can be moved. MR is the resultant moments. Moments due to couples can be added using the same rules as adding any vectors. So dia boleh add. Example 3.3. Determine the moment of a couple acting on the member shown in figure above. Okay. Yes, right. So we have 150 kilonewton. We have 150 kilonewton moment. Force, and then we can break it into x and y direction. So we have x and y direction. This one is 3/5 times 150, 90 kilonewton. So this one is 90 kilonewton. And this one is 4/5, 150 equals to 120 kilonewton. So this one is 120 kilonewton on x direction. Okay. So the couple moment, okay, the couple moment of the first one, okay, we have, let's say, this area, okay. Okay, kotak tu, the square, we keluarkan, okay, and then we have moment 120, okay. So the distance is, kalau if we run on the center, okay. So we have 120 and 120. So this is our distance. Distance is 1 meter. Then next we have ninety kilonewton. We have 90 kilonewton. So kalau kita buat line tengah, okay, we have line here 90 kilonewton, and this one is the couple of 90 kilonewton, and the distance is 3 meter. Okay, so that is our couple moment. That is our couple moment. We assume that counterclockwise is positive. So for the first one, second one, for the first one, if we fix at the center line, we can calculate 120 kilonewton times D is 120 times 1 meter counterclockwise, and then the second one 90 kilonewton times 3 here is counterclockwise. So both is positive. So that's the calculation of our moment couple. Determine the resultant couple moment of the three couples acting on the plate. Okay, so couple moment. Okay, so dia dah ada bagi F1, F1, F2, F2, F3, F3. Okay, so dah ada noted there. F1. So we look at F1 first. F1, F1. Moment for one. This is our moment. Okay. And then the distance. Okay. Moment, distance, G. Moment one is equals to, so we assume counterclockwise positive, but if we put at D, it is clockwise direction. So clockwise direction. Okay, so it will be negative of 200 Newton times 0.4 meter. Okay, so that one is F1. F2, 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 F2. Okay, so F2 moment at 2 is equals to, we have 450 Newton. If we fix at this one, it will move counterclockwise direction with the distance of, so this is positive, the distance of 0.3. Okay. And last one, final one, we have F300 counterclockwise positive moment F3 is equals to, if you fix here, it will move clockwise direction, so it will negative 300 times 0.5. Okay, so the total moment is negative 200 times 0.4, positive clockwise 450 times 0.3, and negative clockwise direction 300 times 0.5. So we got the answer negative. Negative is in clockwise direction. So the answer is 95 Newton meter clockwise direction. Positive. Okay. If the valve can be opened with couple moment of 25 Newton meter, determine the required magnitude of each couple force which must be applied to the wheel. So we have sigma m is equals to Fd. Okay, so we have m is equals to 25 Newton meter. The magnitude of the couple, so F sama dengan berapa? D, what is our D? Okay, so we have this one, F, 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 we have 0.15, 0.15. Okay, so can you get 83.3 Newton? Okay, can use your calculator. Simple question. So guys, our D is, oh salah, so we have 25 Newton meter equals to F times 0.3, F equals to, so, okay. Okay, now I need to do this one. Okay, exercise 3.5. Now, two couples act on the cantilever beam. If F equals to 6 kilonewton, determine the resultant couple moment. So F equals to 6 kilonewton. This is 6 kilonewton. Okay. Okay. Please count your couple moment. Dapat? Boleh? Okay, so what did you need to do? You need to find your um, moment. Okay. Okay. Right. So you have F equals to 6 kilonewton. 6 kilonewton. Then you have this one. So you can separate your force 4/5 times 5, 4 kilonewton, 3 kilonewton. This one is 3 kilonewton, 4 kilonewton. Then you have um, another one here is 6 kilonewton. So you have 6 sine 30, 6 cos 30, 6 sine 30, 6 cos. Soalan ke?
Excuse me, sir.
Ya. Ya, ya. Ada soalan? Oh, 3 kilonewton. You have a triangle, okay? And you have this one, 5 kilonewton. Just use the proportion of the triangle to get the using x and y direction. So you have here is 4, 3, 5. This is the triangle, and you have the value of uh, your force is 5 kilonewton. So just use the triangle to get your, this one is 3 kilonewton, this one is 4 kilonewton. Okay, if 4, 3, 5, if they give you your force is 10 kilonewton, let's say 10 kilonewton, okay, just use the proportion of triangle, so you will get this 10 kilonewton, this will 6 kilonewton, this will 8 kilonewton. How? Okay, so from this one, 4, 3, 5, so you have your 10 kilonewton force. Okay, then you need to divide it into x and y direction. So it is just use the triangle. Okay, this one is 3/5. It is same like cosine. Okay, 3/5. Sorry. 10 kilonewton. So you break it into X and Y direction. So 3/5 is the same like your if you have here theta. Okay, it is the same like cosine. So if you calculate and you get it back, you will get the same answer. So this one is 10 kilonewton times cosine theta. This is cosine, and this one is 10 to the power of 10 times 4/5, and this will sine is this is cosine. Okay, it is the same if you calculate your angle. So just use the triangle method. Okay, triangle method to get your value force. Okay, boleh eh? So when I separate, when I break the force, so for X direction, this one, and Y direction, this one. So 3 and 4 kilonewton. Okay, so then you need to calculate, let's say you take this one. Okay, okay. So for the moment, okay, so for the moment 3, 4, 6 cosine. Okay, so a moment counterclockwise direction. So for the summation of moment counterclockwise direction at O is equals to, we take this one first. I will take the moment couple of this one first. Okay, so this one first. So we have 6 cos 30, and if you fix at O, it will move clockwise direction. Okay, so it will move clockwise direction. So it will be negative 6 cos 30 times the distance. What is the distance? Okay, the distance. I move it here, and this is our couple. Okay, this is the distance. Distance is 0.5 times at 0.5. So it is 1 meter. Okay. Next, number 2 is sine 30. So if we fix point at O, it will move. This one is counterclockwise direction. So it is positive 6 sine 30 degree times the distance. The distance is this one. Okay, so this is the distance. The distance is 3 meter. 3 meter. Okay, next we calculate 3 kilonewton. If we fix at O, the 3 kilonewton will give you counterclockwise direction. So counterclockwise direction will be positive. So just move it here. 3, 3, 3. So this is our distance. 3 kilonewton times 1 meter. And last one, we have 4 kilonewton. Okay, 4 kilonewton, 4 kilonewton. And if we fix that, our 4 kilonewton will clockwise direction. So that one is clockwise direction. Negative 4 kilonewton times our distance is 3 meter. This distance, okay? Boleh Boleh faham Okay. Then we calculate, we get negative 5.196 plus 9 plus 3 minus 12. Okay. 9, 3, 12, erase. So we have negative 5.196 kilonewton meter. Negative. So the positive is clockwise direction with 5.196 kilonewton meter. Okay. Clockwise direction. It is either you put clockwise this term or you put the arrow. Okay. But if you didn't put, one mark will be deducted. Okay. Direction of your mark. I don't know the direction of your answer. Okay. This is the equivalent force couple system. Okay. Students will be able to determine the effect of moving a force. Find an equivalent force couple system for a system of forces and couples. Ini adalah untuk you move your force. Okay. Before this, I teach you that it will work on its line. Okay. It cannot be moved. Okay. But in this chapter, you will learn how to move your force. Okay. So if this one is 0.6 kilonewton, you want to move it here, 0.6. You can move, but it will add another force. Okay. Which is what we call as moment. So you can move the same magnitude of force F, and then it will have additional force, which is moment. Okay. When a number of forces and couple moments are acting on a body, it is easier to understand their overall effect on the body if they are combined into a single force and couple moment having the same external effect. So it is just we want only one F and one moment, only one value, so that we can determine what will happen to our body. The two force and couple system are called equivalent systems since they have the same external effect on the body. So it is equivalent. Okay. We before this, from our previous chapter, we try to calculate our resultant force for Fx and Fy, our theta. So it is same like for the moment, we want to find our equivalent system. Moving a force on its line of action. So moving a force on its line, moving a force from A to O, okay, when both points are on the vector's line of action, does not change the external effect. No, I've said from the calculation of the moment, we can move during the line of action. Hence, a force vector is called a sliding vector, so we can move. But the internal effect of the force on the body does depend on where the force is applied. So if you push your hand here, okay, you will feel the force here. And if you pull it here, you will feel the force here. It is what the effect on the body or the force applied. So it depends on where the force is applied. So it depends. Okay, so this is the resultant of force and couple system. When several forces and couple moments act on the body, you can move each force and its associated couple moment to a common point O. So just move it, bring F1 to point O, bring M1 to point O. So we need just one point to calculate our body. So in that point, we will have our resultant of the forces. Now you can add all the forces and couple moments together and find one resultant force couple moment pair. So we have a force and couple moment. So this is resultant force couple moment pair. So we have one force, we have one moment. Okay. Resultant of a force and couple system. Okay. You know that M is equal to F times D. If the force system lies in the XY plane, then the reduced equivalent system can be obtained using the following three scalar equations. So sama lah kita ada X, Y, and additional M. Okay. So from this one, it is equivalent to this one. Okay. From the figure, it is equivalent from F1. Okay. F1 times D1. You can move this one is F1, but you have add another force. Okay, so you have at M1 equals to F1 D1. And then for F2, you want to move here. So you have F2. Both F1 and F2 you put at point A. You can move F2, but you have an additional moment F2 D2. Okay, so the total is you still have your force. So the same force, the total force when you move. So the magnitude is the same. Okay, but you have add another force of moment. So moment is the total of F1 D1 plus F2 D2. Example 3.5. Okay, so we have 3 kilonewton, 3 kilonewton, 5 kilonewton, 4 kilonewton. So 3, 4, 5. Okay, replace the force and couple system shown in figure by an equivalent resultant force. So nak tahu resultant force and couple moment acting at point O. So kita nak tahu kat sini. This is our point. So what do we need to do? We can have, actually we will separate or break it into X and Y direction to get our M equals to F times D. So this one must be 90 degrees. So untuk memudahkan kerja, you need to find your perpendicular or D, distance. Okay. So resolve all forces into X and Y, sum all forces, Fx, Fy, so kita ada Fx, ada Fy. Then from Fx, Fy, kita ada resultant force. And then theta. And then sum all moment. So this one is force. And this one is moment. And this one is F and moment. Okay. Okay. This is how we gonna get. So we break, let's see our 3 kilonewton, 3 kilonewton first. Okay, so we have our x direction, 3 kilonewton cos 30, 3 kilonewton sin 30 for y direction, and then using 4 kilonewton is in y direction. So then x direction we have 3 over 5 kilonewton and 4 over 5 kilonewton in y direction. So for x direction, we just add this one x direction and this one x direction. Okay, so 3 kilonewton cos 30, 3 over 5 kilonewton. So the force is acting on the right direction. Okay, and then Fy. So this one is y, y, and y direction. So y we have 30. We assume going up is the positive, and then we have 3 kilonewton sine 30 minus. So this one is minus going down, and this one also minus. Okay, so we have minus, minus, and negative means the resultant force is going down. So we have 5.598 kilonewton, 6.5 kilonewton. So same with our second chapter, resultant force. We calculate the resultant force using Pythagorean theorem to get our resultant force, and then we find our theta. So theta is, okay, this is the theta. Okay. And then moment summation. The moments of 3 kilonewton and 5 kilonewton about point O will be determined using their x and y components. So at point O, okay, at point O, so moment counterclockwise positive. So for the first one, we have, sekejap saya ambil lagi sikit lagi. 3 kilonewton ni at point O. Okay, 3 kilonewton 3 sin 30. Okay, 3 sin 30, this one. Okay, this one is acting counterclockwise, so positive, and the distance is 0.2. 3 sin 30, 0.2. Next one, we have 3 kilonewton cos 30, this one. Okay, and this is clockwise direction. Clockwise direction is negative 3 kilonewton cos 30 times 0.1 meter, the d. Okay, we have solved this one, this one. So next, using 3.5, this one, okay? So we have this, and this is our distance 0.1. This is counterclockwise direction. So positive 3.5, 3 over 5 kilonewton times 0.1 meter. Then we have this one. So this is the line of action, and this is our D. So D is 0.2 plus 0.3. So we have 4 over 5 clockwise direction, negative 0.5 meter. And finally, we have 4 kilonewton acting to the O, okay? And the distance is 0.2. This one is clockwise direction. negative or 0.2. So we find our moment. Okay, so that's all for our discussion in this chapter. So this is another example that you can have a look. There are another two examples that you can look at and understand. And it is actually how do you define the point? Okay, point A, here point A, and then you move your F, you separate your F and move it at point A. Okay, so this one also the same at point O. So you fix your point O and move your calculate your moment, couple moment of at point O. Okay, so that's all for now. Tomorrow we have a quiz in class time for about 20 minutes. And last one, siapa yang belum tulis attendance? Okay, siapa, any of you that not yet fill the attendance form, please click the link on the chat box and fill in the form. There are 47 participants, 47 students that are actually response to the attendance. Okay, so today that's all from me for this chapter, and see you guys tomorrow at 10 with quiz. Okay, thank you very much, and class dismissed. You're welcome. Thank you very much. You're welcome. Okay, left sekarang. Siapa tak left, saya anggap dia tak ada depan komputer. Cepat left, cepat left, cepat left, cepat left. Cepat left, cepat left, cepat left. Melainkan kalau ada soalan. Kalau ada soalan nak tanya boleh. Ha. Siapa tak left, saya screenshot. Ni tak ada depan komputer. Kelas dah habis. Tak ada depan komputer. Okay, 1 minute. 1 minute untuk left. Recording another 1 minute. 1 minute. So siapa yang ada lagi ni, tak ada depan komputer lah dia. 40 seconds. Thirty seconds. 20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.